Circle A has an inscribed angle of 75 degrees. So let's go ahead and draw a circle. And let's draw an inscribed angle. Remember, an inscribed angle goes to the back of the circle. And it says that this is 75 degrees. Then it says the length of TV. So this was TLV. So they're saying that the length of this from here to here is going to be 15 pi. Maybe it's 15 pi centimeters. Maybe it's 15 pi inches. We just know it's 15 pi. Then it says find the radius of the circle. Well, this is a length. Length always deals with circumference. So the formula I'm looking at is, remember we dealt with like a sector? We always had like that x degrees divided by 360. Well, this is circumference. So we're going to say the length of TV is going to equal x degrees over 360 times, since it's length, we're going to use circumference, which is 2 pi r. We know almost everything that's in this equation. What is the length of TV? Well, that's 15 pi. What is that degree I'm going to put for x? And I'm asking that. Yeah, Stephanie.
150?
It'd be 150. Because it's an inscribed angle, we double it to get the arc at sub 10, so this would be 150 degrees. So this is going to be 150 divided by 360 times 2 pi r. Well, that's just an equation we need to solve. And I want you to go ahead and solve it. I'm going to give you about a minute. You should come up with r equals 18. I'm just going to double check that I had that right. Just to save a little more time. So I would divide, what I'd start off with doing is I would probably divide both sides by 2 pi. Where our pi's would cancel out and our 2 pi's would cancel out. That would give me 15 over 2 equals, I'm going to change that 150 over 360 to just 15 over 36 times r. Now all you have to do is multiply by the reciprocal of 36 over 15. So we're going to multiply by 36 over 15, which would cancel that out. So remember, we're distributing this to both things. And 36 over 15 times 15 over 2 is going to turn into 36 divided by 2, which does equal 18. So this is one of those cases where you don't want to just plug stuff in your calculator. Your calculator is going to come up with a whole bunch of decimals. This is one where you want to kind of keep it in fractions and we can keep a whole number. So we're going to end up with r equals 18. Does that all make sense? Don't forget about this very important math skill. If you're not sure what's happening up here, write an equation that we did. The only equation we did that dealt with arc length was arc length equals x over 360 times 2 pi r. Just like if I said the sector equaled 24 pi, you go, okay, 24 pi equals x over 360 times pi r squared, because that would be area. Know those two formulas inside and out, and it's going to make your test experience a lot easier. Okay? All right, questions from the homework. Sahej.
Number 25.
Number 25. Let's see if I can find it. Yeah, I'm only going to go over one of those, so either 24 or 25. So we'll go over 25. All right, let's go over 25. Do you have, is it blank on yours?
Yeah.
Can I go ahead and take a picture of it?
Yeah.
Thank you. All right, 25 is this. 25 says that we have a trapezoid. And it says A, we're supposed to compare 1 to 3. So our A, let's do our A over here. A. We are comparing 1 and 3. What are 1 compared to 3? Our first question should be, are they similar? If they're not, we're going to go bases and heights being the same. Are those two similar? Yeah, they absolutely are similar. It told you that this was a trapezoid. Since it's a trapezoid, we would have these two lines are parallel. So these two angles would be congruent, these two angles would be congruent, and these two angles would also be congruent. So they're definitely similar. So if you looked at my notes, I said that they were similar to each other. In order to deal with similar objects, we're going to do a scale factor, and then we're going to square it. So the first thing is our scale. Our scale factor of 1 to 3 would be 8 over 18, which we can simplify down to 4 over 9. That means my area ratio. So what do I do to find my area ratio? If I know my scale factor, how do I get to my area ratio?
Wouldn't you square it?
You would square it, yep. So we would have 16 over 81. That is my area ratio. Perfect. Our next one says we're supposed to do, what is that? 1 to 2. So our B is 1 to 2. So if we look at 1 and 2, this word starts getting a little trickier. Would you agree that they have the same height? Do you see that? So let's go to that point right here. Put a right angle on there. That's the height of both of them, right? Because it's the right angle to both of their bases. This base we could extend. It'd be a right angle. So they have the same height, so we're looking to compare the ratio of their bases. Do they tell me either one of these lengths? What can I do if they don't tell me either one of these lengths? Yeah.
Would it just still be 4 over 9?
It would still be 4 over 9. Perfect. So the scale factor between 1 and 3 is 4 over 9. That came from our 8 over 18. Well, if you look at the base of 2, the base of 2 is right here. That is the side of 3. The base of 1 is this side here. Since the scale factor, that 4 over 9, works from 1 to 3, it's going to work for these two sides. So this is going to be 4 over 9. So yeah, so our area ratio of 1 and 2 will be 4 over 9. Note we don't have to square it, because if it's same base or same height, you don't square it. That's our B. Our C says, what does C say? C says 1 and 4. Same height? Are they both the same height? Yep. They're both the exact same height. We could prove that. We could show that by just drawing a straight line down here and saying that's my height. They both have the same height. So I'm comparing their bases. What is the ratio of their bases using that exact same premise we did from B? Like 4 to 9. So our area ratio would be 4 to 9 again because it was based upon that scale factor between 1 and 3. Area ratio is 4 over 9. D is really filler. D says compare what? It tells me do 2 and 4. Well, 2 and 4, note what's kind of happening here. 2 and 4 are actually going to be the exact same triangles. Just because of how the ratio, since this is 4 to 9, this is 4 to 9. These both are the same to 1, so they must be the same to each other. So 1 and 4 are the, or 2 and 4 are the exact same triangle. So that's going to be 1 to 1. Okay, now when we are comparing, so our last one is E. I'm supposed to compare 1 to the entire thing. So we're doing 1 over, basically the entire trapezoid is 1 plus 2 plus 3 plus 4. Note our ones on top are slightly different. They all have to be the same value. Note I have a 4, a 4, and a 16. All of these stand for 1. Are we all in agreement of that? Because this was 1 to 2 is 4 over 9. This was 1 to 4. This is 4 over 9. This was 1 to 3. That was 16 over 81. So all of our tops are referencing area 1. Well, I'm going to tell you right now, for our area 1, we're going to use the number 16. We're going to use the number 16. So anytime you see a 1, you're going to use 16. So we're going to have 16 over 16 in place of this 1. Now for 2, it almost looks like we should use 9. But we can't. Is there a 16 on top of here? Remember, I'm saying every time I see 1, I need to see 16. So we need to turn that 4 into a 16. What do I have to multiply 4 by to make it 16? Yeah. By 4. So what we're going to do is we're going to actually multiply this by 4 over 4 to equal 16 over 36. Now I have my 1 being 16, which means now I can use this 36. This 36 is going to take the place of area 2. So we're going to have 16 plus 36. I'm sorry, that was the place of 2, right? All right, what's going to be for 3? What number are we going to use for 3, area 3? What was that? Look at the one that has 3 in it. See the 1 and 3?
Yeah.
Is our 1 16?
Oh, so just 81.
It'd be 81. Yes, we're going to use the 81 from that one. Perfect. So that one I'm going to use 81. You're looking at number 4, right? Number 4, what number would I use?
36.
I would use 36 because once again, for this one I have to multiply by 4 over 4, which would equal 16 over 36. So this would be plus 36. We do all that addition, you come up with 16 over 169. Tough problem, yes. Is it possible we have one like this? Maybe not as big, but we could definitely have a smaller version of this on the test. You do have to understand how to compare ratios. So Hedge, did all the steps at least make sense?
Yeah.
That way when you look at it again, you can study it. Any questions on anything I did here? Now's the time to ask. Don't go. I have no idea what's happening here. Yeah.
I'm still kind of confused on why you multiplied all of them by 4.
By 4? Okay. That's a great question to have. So,
Is it because the top is 16?
it is because the top is 16. I am saying I want to replace 1 with 16. So when I'm dealing with this ratio here, I need to know 4 to 9 doesn't help me. I need to know if my ratio on top is 16, that's the only way that helps me. So every time I have 1, I need to have a 16 in that place. So they weren't 16, so I had to multiply everything by 4 to see how, if it was 16, how I could then compare it to that one. So whatever number I put on top of here, all of these have to match up to that number. All right, other questions from the homework? Gone once? Twice? Okay. Today we're going to talk about probability. Geometric probability. You've probably seen probability before. Probably have seen probability before. What's the probability you saw probability before? Hopefully it's 100%. All right. Probability is the likelihood that an event will occur. So if I'm rolling a die and I want to roll 6, the probability of that happening is 1 out of 6. Because there's only 1 6 on a die, and there's 6 possible outcomes. So it is basically success over how many possible outcomes there are. Geometric probability is probability that involves geometry, geometric measures. Is that what I put? Yep, geometric measures. So rather than rolling a die, we're probably going to have stuff like, if I'm throwing a dart at a circle, what's the chance of me hitting a smaller circle compared to a bigger circle? So we're going to be basically finding areas of things and seeing how it compares to a bigger area. Note, there are three ways that we can express probability in an answer. The first way we could do it is we can use a fraction. So our fraction might be 3 over 4. We could use a decimal. The decimal version of that would be 0.75. Who wants to guess the last way? Three or four is a ratio. So we could do 3 to 4. I'm sorry, that would make it a fourth way. What can we usually turn? I guess, what do we normally say? Percents. I said it. We could also use percents. So in this case, we move the decimal place 2 places, and we'd end up with 75%. But yes, Ed, you are correct. We could use just regular ratio. We could go 3:4 also works. The fraction kind of holds that place because we can always write a fraction as that. Okay, those are our 3 main ways on the test. Unless I specify, I don't care how you give me my answer. Most of the time, I'm just going to leave it in fractions because as soon as you go further than you have to, that's when you make that dumb mistake and have to take a half point off. Like you might have came up with 3 over 4, and all of a sudden you're like, that's 0.6. And I'm like, why'd you go that extra step? 3 over 4 is correct. All right. The first thing we're going to talk about is length probability, and then we'll talk about area probability, and those are our 2 major geometric probabilities. So length probability, it says if a line segment AD contains another line segment BC, so BC is part of AD, and a point on segment AD is chosen at random, what is the probability that it is on segment BC? So that means I close my eyes, and I doubt I can even find the line, but say I close my eyes and I point to the line. Am I anywhere near the line? Am I really? Oh, it's probably the best I've ever done ever. What is the probability of me closing my eyes and putting a point somewhere on here and it happens to be BC? Well, we're going to do success over our entire thing. In other words, part over whole. So I'm going to consider me putting my finger on the line successful, but in this problem, our success is line BC. So our part, so we're going to go length. What is the length of BC over what's the entire length of the line? Length AD. In other words, it is part over whole. That part that I want over what's the total places my finger could land. Part over whole gives us our geometric probability. Surprisingly enough, that's the exact same thing we're going to do with area probability, except we're expanding it to 2 dimensions, or a third dimension, 2 dimensions. That's really just one. It's just length. So now we're just really expanding. It says if region A contains a region B, and a point in region A is chosen at random. So once again, I close my eyes, and I just... There we go. I close my eyes, and I point to it. What's the probability that I actually get inside B? Well, that's going to be the success is the area of B. Area of B divided by our total area. So that would be area of A. Once again, that is part over whole. Now be careful on these problems. A is not just this blue region. What I'm talking about A, when I talk about A, I'm talking about the entire, let's make that a little thicker. When I'm talking about A, I'm actually talking about this entire thing. So that is actually blue plus that one. So I'm talking about that entire region there. I wonder if I said that differently in my notes. No, I didn't. But yeah. So area of B compared to this entire area here. So really, it kind of, in the picture-wise, it'd be A plus B. I think on your sheet it looks a little different. All right, let's put that in practice. All right, our example, we have point X is chosen at random on JM. So we know that the point is landing on this line somewhere. It can't go off it, it's going to land on a line. What's the probability that X is on KL? Well, we're going to do part over whole. The part I think is successful would be if it landed on KL. So I'm looking for the length of KL. Well, our entire length is the entire JM. So we should probably get that entire length down. So if I'm talking about the entire length, that would be 3 plus 7 plus 4, which would be 14. Our entire length is 14. So that means JM is 14. KL is 7. So our probability is 7 over 14, which I'd probably simplify down to 1/2. You have a 50% shot that if you just randomly point on that line, that you would land on that specific spot. Our next one is find the probability that X is not on JK. The point is not on JK. So I'm successful if it's not on JK. Where would it land for it to be successful, I guess? Yeah.
3/4.
Say that again?
3/4.
Oh, 3/4. That'll be the answer. I'm just looking for, so not on JK would be KM. Yep. So that would be KM. Yeah, you got it. So I'm actually looking for when is it KM that is not, that's everything that's not JK is KM. We still go over JM. K to M, that distance is going to be 11 over 14. And that's as far as we're going to go. It's just 11 over 14. Can't simplify that. Okay, so sometimes when I say not, you have to think about where it would be successful. So JK wouldn't work, but KM would work for all those. Our next one has area in it. It says I'm basically throwing a dart. So this is a figure created by placing rectangles inside a triangle inside a square. If a point inside the figure is chosen at random, what is the probability that the point is in that shaded region? Well, how do I calculate the area of this shaded region? Yeah.
Oh, you just find the area of the square, or the area of the triangle and subtract the square.
Yes. So the area of this shaded region will be area of the triangle minus the square. So let's go shade area. Underneath that, I'm going to go triangle minus square. Triangle's half base times height. Don't let those threes confuse you. The base of the triangle is actually 9. So our triangle is going to be 1/2. Our base is 9. What's the height of that triangle? Yeah, 9 as well. Because they gave me this little sign over here. Maybe I'll highlight that in red. This is, oof, that's a bit aggressive. This is a 90 degree. And so this right here is the height of the triangle. So the height is 9. So that's going to be 1/2 of 9 times 9 minus the square. The area of the square is 3 by 4. So we're going to have 3 times 4. I do believe I just used decimals in this one. So that's going to equal 28.5 centimeters squared. Is that correct? Yeah, like.
Would this square be a rectangle?
It is a rectangle. Yeah. Because it is a rectangle inside a triangle inside a square. So it would actually be a rectangle. So yes, it'd be triangle minus a rectangle. All right, that's a shaded region. I have the shaded region. What other area do I need to find? Yeah,
The whole.
the whole. So we're going to do our whole area. Our whole area is just going to be that square, that big square, which would be a 9 times 9, which equals 81. All right, our probability is going to equal the shaded region divided by that whole area it could possibly hit. Well, we said the shaded region was 28.5, and that would be over 81. Now, note there's a decimal in the fraction. Generally speaking, in math, if there is a decimal in your fraction, that's where you plug it in your calculator and you approximate it. If there is no decimal in the fraction, we just leave it as a fraction. So that decimal kind of tells me, well, let's write this as a decimal, which would be about 0.35, which we could also write as 35%. Now, it didn't ask for percent, so on a test, if you stopped right here, you have the correct answer. If you went further and got 35%, also a correct answer. Just look at what the question asks you. If I say put it in percent, you do have to go that extra step to put it in percents. The only reason why I did it is because as a mathematician, if we have decimals in a fraction, we generally round it then. All right. Our next one says, every 10 minutes, a bus pulls up to a hotel and waits for 2 minutes while passengers get on and off. Then the bus leaves. If a person walks out of the hotel front door at a random time, what is the probability that the bus is still there? All right. So every 10 minutes, a bus pulls up to a hotel and waits for 2 minutes. So let's talk about that 10-minute interval. So let's make a 10-minute interval. That is going to be my 10 minutes. It doesn't matter where the bus shows up because it's a hypothetical bus showing up for 2 minutes. I'm just going to put those 2 minutes right off to the front. You'd still get the same answer you put in the middle. You'd still get the same answer anywhere you put it. We just have to put, there's a 10-minute window where the bus is there. So let's go ahead and put, did I say 10 minutes? There's a 2-minute window when the bus is there. So let's go ahead and fill in like a little section here and say that that is my 2 minutes the bus are there. So every 10 minutes, the bus pulls up to a hotel, waits for 2 minutes, and then takes off. This is that block of time that 2 minutes is. Like I said, you could have put this anywhere on this number line. Generally, I'm just going to put it in the front because it makes it easier for subtraction stuff. How much time is the bus not there then? 8 minutes. So this length right here is 8 minutes. Not that important, but it's good to know. All right, that's just a linear problem. That is just length. Think of 2 minutes as my length. We have 2 minutes where the bus is here out of a possible 10 minutes. So this is still part to the whole. The part where the bus is there is 2 minutes. The whole is 10 minutes. So you're going to have a 1 in 5 chance of just randomly going outside and the bus is actually there. All right, number 4 says, a person who just beginning archery lesson misses the target frequently. True. And when a beginner hits the target, each spot is as likely to be hit as another. If a beginner shoots an arrow and hits the target, so we're not worried about any ones that they miss. We're talking about just the ones that they actually hit the target on. What is the probability that the arrow hits the bullseye? The bullseye is the very center circle. The very center circle. What are the 2 things I need to calculate? What are the 2 things I need to calculate in order to get the probability of hitting this red circle right here? I just need 2 areas. Length?
The area of the big circle.
The area of the big circle and
The
Area of the little circle. Those are the only two things I need. So this 2 right here is just to throw you off. I'm looking for a bullseye, so that's just the red circle. Our total area is the big circle. So those are only 2 things I need. We need a total area and the bullseye. So let's do our total area first. Well, the good thing is it's just a circle and we know the radius. So that makes our life a little easier. Area equals pi r squared. So this is going to be pi times 3 squared, which equals 9 pi. Need that number. All right, 9 pi, I need that number. Now I need the area of the bullseye. Once again, that's pi r squared. They gave me the radius is 1. 1 squared is still 1, so that is just pi. So my probability, the probability equals success over total, so that would be pi over 9 pi. Well, pi and pi turn to 1. Oof. So we're just left with 1 on top. And so this is going to equal 1 over 9. That is our probability. All right, that is all I have for you. The rest of the time for you to work and ask questions on the homework. I am going to walk around and I'm going to check your homework that was due